Okay, so here we go. So 4.1, the rest of the deal here. So yeah, that function is y equals the f of x. That's just your y, isn't it? You aware of that? The g of x, h of x, that's what? Oh yeah, the light thing. Huh? All right, so that's the y. I should do that for my other classes. I never thought about that before. So it does clear it up a little bit. All right, so there we go. That's y equals f of x. Function letters are just y. That's by common agreement. Math science world just agreed. F of x, g of x. Function letters, we're just going to play the role of y when it comes to the axis for graphing. That's going to be the y. So, all right, so we have that. Now, what does that mean about how you know whether it rises or falls, positive or negative, all that? Well, I gave you some examples. Let me just remind you. Could I call it A? AX, and I said if A is greater than 1, then it's a graph like this. And if A is less than 1, it's a graph like that. The base. So if the base, the thing that has the x on it, if it's bigger than 1, the graph rises to the right and comes down for a landing on the negative x-axis. And if it's a less than 1, then it falls to the right and comes flat on the positive x-axis. Everybody see that? So, yeah, so if the base of the exponential function is a number bigger than 1, that's going to make the graph rocket up to the right. So basically, these exponential graphs, I know we're just getting going with those, so let me give you the characteristics. These exponential graphs, they're going to basically have one side where they rocket up and the other side where they flatten out. So they have a rocket side and a flat side. That flat side, we call that an asymptote line. You don't need to know the word. Oh, yeah, there it is. Asymptote, yeah. So there it is. So that means a line that it flattens out at, or a line of approach. So, yeah, so if it rises to the right, flattens out on the negative x-axis. If A is greater than 1, if A is less than 1, then it falls to the right and flattens out on the positive x-axis. So what do we have here? Well, here's our base right here. Here's all we care about. We don't care about anything else. That's our A, which is 5, which is certainly greater than 1. So it's going to look like this, isn't it? Which means it flattens out on the negative x-axis and it rises. That's why it rises. Negative x-axis is the horizontal asymptote. Is that good? Making sense how we identify that? It's all about that base number. When x climbs into the power zone. You with me on that? That's what it means to be, well, exponential function. It means x has climbed into power. In other words, if I had x cubed, x to the third, I'm on the third racer. If I had x to the third power like that, that would not be exponential. This is not exponential. Why not? It has exponents, right, but x is not in the power zone. You with me? It's not just that it has powers, but to be exponential, x itself must climb up there into the power zone. That's what we're talking about in this section. Functions where x itself has climbed into the power zone. All right. Okay, so y, f of x, same as y, 4 to the x. So remember, when this number is, a is greater than 1, when the base number is bigger than 1, it goes up, huh? Bigger than 1, it goes up. Less than 1, it falls. So yeah, boom, done, huh? That easy. It's not a straight line, and it's not a U shape. Those are silly answers. So we got it. We good on that? Just multiple choice on that. All right, I'll keep moving. Okay, so number 6 here. Y equals 1, 6. Again, x has climbed into the power zone, so it's exponential. Now, here's my base, my A. A is less than 1, isn't it? 1/6, that's a fraction less than 1. 1/6 of a pizza is less than 1 whole pizza, right? That's less than 1. So what does that mean when the base is less than 1? It falls to the right. instead of goes up. And you get a 3x5 card on the exam, so you can put pictures of, you know, greater than 1, up, less than 1, goes down. So which one is that then? Just got to be C, doesn't it? Oh, you might wonder, okay, A goes down also, doesn't it? So how do you know it's not A? Yeah, it's because A goes down below the axis. See how A... So this one is going to land on the axis instead of going below the axis. How do you know that? Well, whatever number is off to the right. So there's nothing off to the right here. I could say plus 0. That means it's going to land at a height of 0. Was that too quick? In other words, if somebody gives me, if they gave me y equals 1/6 to the x, say plus 3 or whatever, any number added off to the right, this number added to the right, that's where the flat, the horizontal asymptote is, the flat part. The horizontal asymptote is that number added off to the right. In other words, I could draw this graph. This is plus 3, that'd be up 3. Right there at up 3. And then the graph would fall down to that level. Does that make sense? So the number added off to the right is the height at which it flattens out. Since there's nothing added off to the right, it's like there's 0 there. That's why I know this one flattens at 0, whereas this one's going down below 0. So that's not right. You good with that?
Would be like -1 for A.
It looks like it to me, yeah. This would look like -1. This one looks like y equals 1/6 to the x minus 1. I agree. It looks like it's coming down at -1, huh? Yeah. Something negative. It's not 0. Yeah, good. Okay, so yeah, let's do this first one. So f, or y, same thing. 2 to the x minus 3, and then g down here, which is which? Right, and then g is 2 to the x. Okay, so basically they're wanting me to say which one is right. Well, both of these go up to the right, don't they? Both of these, this and this, both have an a value greater than 1, don't they? So they're both going to go up to the right, aren't they? You with me? So that, just from that reason alone, that's the only graph where they're both going up to the right. Both of these have an a value that's positive. What this x minus 3 does, it basically scoots the red graph back 3. Oh no, that's not true. It does reverse. Yeah. Anyway, don't worry about it. I'm not going to make you learn things that they're not required. We can tell that A is the right answer there because of the fact that that's the only one where they're both going up to the right. If we need to later, I'll teach you what it does to do that. But for now, it doesn't seem like we need to worry about it. They both go up to the right. A is the only one. They both go up to the right. A is the answer. Okay, so 2x minus 3, so f here is 2. Now the minus 3 is down on the base level. Does everybody see that difference? Let's look back. See right here how the x minus 3 was all up into the power zone? Whereas on this one, the minus 3 is down on the base level. See that? It's not in the power, so that's a little different deal. What's that going to do? What's a number added or subtracted off to the right? Let's flash back. Number added and subtracted off to the right is your horizontal, your flat line, the line it levels off at, your horizontal asymptote. Yeah, the number added or subtracted off to the right, right? I showed you if it was plus 3, this would be up at plus 3, the flat line where it flattens out, you know? So if it's minus 3, then what does that mean? Well, that means 1, 2, 3, down here at minus 3. I'll do a dotted line. So what you usually do asymptote lines is dotted because they're not really part of the graph. They're invisible, but they're just there as a guideline. So that would be where it would flatten out. Now, does this graph go up to the right or fall down to the right? Which one does this graph do? Look at A. Up. A is greater than 1, so it's this kind, it goes up. So that means it flattens out here, and Goes up like that. So that's what f must do. Does that make sense? See how I knew that? It has to go, a is bigger than 1, the base. The base is a number larger than 1, so it has to go up, not come down. Only when the base is less than 1 does it come down. And the -3 out here means the flat line is -3. So that's A, and then that's F, and then G is just regular. Oops. G is just 2 to the x, meaning, what do I mean by regular? Well, I mean he's got a understood plus 0 out here. So he's going to be on the 0 line, and he's going up to the right also, isn't he? That's what G. So which one of those looks like that? Yeah, B does.
What does A have a straight line?
Yeah, it's just wrong.
Oh,
Yeah, neither of these are straight lines, are they? What kind of an equation produces a straight line like A? Yeah, that'd be linear. That'd be like y equals 3x plus 7 or something, where x and y are both to the first power. But we're talking about x in the power zone for both f and g. These are both exponential, aren't they? So no way, answer A. There's no straight lines here. Good question. That makes sense? Getting the difference in those types of equations? Is it hot in here?
Yeah.
It's warm in this basement. I was just talking to the one of the genders today about how we can get it to be a little cooler. And he says I have to call the official operations people. I don't know. Let's see. So, f of x, I'm just going to take this right here, is a to the x. And they're telling me that f of 3 equals 8. And they want me to find f of 2. That's kind of, so we're changing things up. No more picture on this one. Now we got to work with the equation. All right. So what, are you okay with this kind of a statement? What is that saying? That's saying when you plug 3 into the function, it comes out to equal 8. Everybody see that? Should I make it a little bigger? Okay, so let me take this again, bring it right over here. Okay, then I'll do what they're saying. They're saying plug in 3 and it's equal to 8. So plug in 3, which means right here, put in 3, which means the x right here becomes 3. You with me on that? And it'll, when you do, it'll equal 8. Let me slow down for just a minute. Does everybody see what I did there? So I just took that information, the function they gave me, and I put in 3, right? 3 is in the x slot. So I put in 3 in the x position, and then it's equal to 8. So now I have this little equation. I can solve that little equation for A. Can you solve just by looking at it? Can you tell me what number to the third power is 8? 2. Yeah, A's got to be 2, doesn't it? Because 2 times 2 times 2 is 8, right? That good? So A's 2. Okay, so what? Well, that means, going back to this equation now we know what A is. So this equation becomes not just A to the x, but 2 to the x. Now we know what the base is. The base is 2. Okay, so what? Well, now I can answer the second part of the question, which is find f of 2. F of 2. Where do I put the 2? In the x. Whenever you plug into a function, you're plugging in for x, aren't you? So f of 2, right? 2 is in the x position, is 2 to the 2, which is 4, and we're done. 2 squared, 4, we're done. Is that okay? How are we doing? All right, I'm going to keep moving, but stop me if you want me to slow down. This will be on YouTube. You need to watch it over and slow. Okay, so they're saying f of x equals a to the x, it's just what's right here, and then 249. Now remember, when they give you points, this is x and this is y. You all know that, right? From your algebra days, when you do like the two numbers with the parentheses and the comma, the first one's x, second one's y. Okay, and so the 2, that's going to go in for x, right? No surprise there. Where's the 49 going to go? Y. Where's y? Yeah, remember, f is y. The whole thing. Not just, because I know it can be confusing. I just had somebody in my pre-calc class ask me a couple hours ago, well, Mr. It's got f and it's got an x. Yeah, what I mean is the whole thing. F parentheses X, the whole thing is Y. You don't need to, there's not really both there. Thus, the whole thing is Y. So what is Y? 49. So that means 49 is A squared. Getting a little scribbly there. 49 is A squared? How do I solve for A? Square rooted, huh? So A is 7. So A is 7. So what? Well, that means the function, f of x, a to the x, now I know what the A is. It's 7. 7 to the x. And so we're done. That's all they want on that one. Is that good? So the last two problems we found A by plugging things in. Okay, so it's A, I'm just going to grab this formula right here. C, 1 plus R to the x, and then they're telling me C is 200, R is 19%, and X is 18. Just plug them all in. So 200, 1 plus R, and what do you do for 19%? 0.19, right? Make it a decimal. X is 18. So you just hit the buttons on your calculator at that point. So it's just, what I mean by it's just a plug-in. Sounded all fancy, but it's just a plug-in. So 200, I'll get the number, see if you can get them too. 200, 1.19 to the power 18. I'm getting, what am I getting? 4580. They want nearest 100, 4580.10. Did y'all get that? You able to get that? Did you guys get your calculators over in the library? Get your graphing calculator so you don't have to pay $100. They're available over there. I mean, I think they are still available over there.
I went today.
Did you went today? And they were still there?
No, just like 30 minutes ago.
And they had them. Excellent. All right. Good. Yeah. Pick up your graphic. We'll need them. There'll be things you have to have it for later. So we good there? Questions on that? All right. These are actually not bad. They're just a plug-in. Sometimes they are bad, but these last two aren't. So okay. So they give me this fancy formula. I'm basically just going to plug into that formula. You don't even need to read all the words. Blah, 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 blah. Who cares? Right here. Here's all we need. X is 0 is the year 2000. They just made that up. That's how they do real-life science formulas a lot of times. They'll pick a starting point. So they'll say, all right, we're going to use this formula to predict how many cell phones in the country as they grow over time, And we'll say X equals 0 is the year 2000. Okay. So down here, if they ask me about the year 2007, how many cell phone accounts in the year 2007, what does that mean X is? Yeah, 7, because that's 7 more than the year 2000, right? So they're just saying, hey, take X equals 7 and plug it into the formula. That's all they're saying. I just grab that 7 and I plug it in right there. So it's 110.8 E to the 0.125. Oh, you familiar with the E? The E is going to be a button on your calculator. So you should find it right above the ln key. Natural log, it's right above the natural log key. So type that into your calculator. See if you can get that to work out. I'm glad to help you after class. Each calculator is a little different, so probably got to be individual. E to the power, 0.125 times 7. I'm getting 265 point, what, 7, how far? 1,000. So I'm getting 795. Thousands means 3 places, right? 3 zeros and 1,000. 795. Did you guys get that? Did you find the E button? It's right above the natural log. So you got to hit second natural log on most calculators. I can write out. So what I hit is I typed in 110.8, then I hit the second ln, and then 0.125 times 7 equals. Here's what I hit on my calculator. If you have a TI, probably like that. It might be a little different on other ones. You able to get that okay? So again, I'd encourage you to bring your calculators to class because a lot of what we do is getting used to using them right here. Things I can answer? Is that okay? Did I already say feel free to bring your computers and stuff and get some of your homework done during class if you can do that? Have I said that? I forget which class is that. So then I haven't said, okay, yeah, feel free. You want to bring your phone. You know, some people, like, this stuff's just easy for them. They're just like, oh, yeah, I know that. Feel free to get half your homework done in class, on your phone or your laptop or whatever. And also that's helpful to me a lot of times because you'll see a question. You'll be, hey, Mr. Aaron, can you show us number 14? It's really tough. And I would have not noticed or something, and I can do it for everybody. So feel free to do that. Can you get Wi-Fi? Or you can get Wi-Fi down here, right? Mm-hmm. Okay. Well, yeah, I'm on Wi-Fi. Silly question. Yeah. All right. We good there? So grab me after if you're having trouble with the calculator. Okay. So first off, part A, B, and C are simple. They're just plug in. It says the amount of plutonium starting with 1 kilogram after X years. So basically, this is an exponential decay function. You don't really need all the background, but basically, you take this plutonium stuff, and over time, it just kind of decays into the atmosphere. If you put a pile of plutonium on the desk here, then a year from now, it would have shrunk a little bit, meaning some of it dissipated, decayed into the atmosphere, and there's less and less and less and less over time. That's what that formula is. It's predicting how the weight, the W is the weight, the amount, will go down over time. See the negative power? That means it's going to be decaying, going down over time. It's called exponential decay. So anyway, they say how much will be left after 4,000 years? So X is the years, right? So just plug in, X is 4,000. Just take 4,000 and put it right there. So W equals 2 to the negative, let me get this out of the way, 2 to the negative 4,000 over 24,360. That's all I do is plug in X is 4,000. And then part B, C are the same kind of thing. Now, can you do that in your calculator? Let me help you with that. So how would you do this on your calculator? 2 to the power. Now, the power button is like an up arrow on the TIs. It's a X to the Y on some calculators, depending on your power button, you know. And then you would go parenthesis negative 4,000 divided by 24,360, hit equals. That's how you would type it in. Now, you know on the TIs, the negative is different than the subtract, right? Or on pretty much all the calculators. And calculators get really upset if you reverse those. They give you syntax error. They won't do anything. It seems kind of funny. They're so upset about that. But so negative, the negative is down at the bottom. Do you guys know what I mean? The negative on most calculators is down in parentheses on the bottom. And negative is different than subtraction. All right. Let's try that. So 2 to the power negative 4,000 divided by 24,360. I'm getting 0.89. There's an answer. How many places they want? 2 decimal. So I'm getting 0.89 for part A. 0.892, blah, blah, blah. So 0.89, did you all get that? Is that coming out? Notice how I put parentheses around the power. Let me using calculators well is going to be a lot of what we do in here. So if I can say a couple of words, not only like, hey, there's the exact steps, that's good and everything, but if I could give you a couple words which would help you like generally think how your calculator thinks, then you would kind of know what to do in a lot of situations. Basically, why do I need the parentheses? If I just type in 2 to the power of negative 4,000 divided by 24,360, that will not be right. Why not? What's the calculator thinking? Why doesn't it know? You know what it is? If there's no parentheses, the calculator only does the first thing in the power zone. The rest it does outside the power zone. It doesn't know all that stuff's in the power zone. In other words, it'll just go 2 to the negative 4,000, and then it'll divide that whole thing by the 24,360, which is totally wrong. We want the 24,360 up in the power zone. Calculator doesn't know that, though. So the calculator, whenever you have more than one thing in a zone, you have to tell the calculator that. You have to signal the calculator. Say, hey, calculator, the 4,000 and the 24,360, that's all in the power zone together. The way you tell the calculator that is the parentheses. The parentheses group it together and say, it's all in the zone. Then the calculator does the right thing. Does that make sense? If you don't give the calculator grouping symbols, it'll just do the first thing and then go back to regular after that. So always be thinking that way. Whenever you have, and that works for like a fraction. If you have more than one thing in a numerator, more than one thing in a denominator, more than one thing in a power zone, you have to put parentheses around that whole zone to tell the calculator correctly how to handle it. Questions I can answer on that? So that would not be right. That good? So we'll go on. So part B is the same, part C is the same, no big deal there. Let's go to D though. D's got a trick. Can I move along? You good on that? I'll go to D. Questions on that part? Okay, let's do D. Because D is tricky, really tricky. Estimate how long it will take for 1 kilogram to decay to half its weight. So they're being super tricky here. So first off, just think real with me. If I said, hey guys, I had 1 kilogram and then later it was half that. So what is that? What's half that? What's half of what? 0.5. So let's be clear. We're talking about 0.5, right? That's half of 1. 1 kilogram became half of its original. So now it's 0.5. Okay. So where do I put that 0.5? Do I plug that 0.5 in for x? No, it's not x. It's the weight, huh? So it's the whole left side. Again, don't let the, I know for a lot of students, like the parentheses kind of confuse them, and they think, well, I'll make the w 0.5, but then I have the x there too. No, don't let that confuse you. If it bugs you, just say this is all w. Those parentheses x, that's just the plug-in. That's like the holes in a toaster. You know what I mean? It's not really separate. It's just part of the w. So if it bugs you, just make that a big W. That's what it really is. So it's just W on the left side, and I'm going to make that whole left side 0.5. Because this is weight, isn't it? This is the weight, the kilograms of the stuff. So they're saying, hey, take that formula and let the left side, the W, be 0.5, half. Okay, I will. 0.5. We good to there so far? They said the weight is half, so the W, the left side's 0.5. Now, they want me to solve this equation for x. How do we do that?
Can you get rid of that fraction?
What's that?
Can you get rid of the fraction up there?
Get rid of the fraction? How so?
By multiplying it instead of
What do you mean, Joel? Tell me.
24,360.
Oh, gotcha. Well, the problem is it's up there in the power zone, though.
Yeah.
You know, how do I get at it? If I just multiply the left side, and the right side by 24,360, it won't really get up into the power, will it? That's the weirdness of this. See how weird this equation is? I mean, we got a weird old power thing going on there. So, let me just cut to the chase. Here's the trick. 0.5 is a half, isn't it? You with me so far? 0.5 is a half, right? Just another way you could write it. Okay, great. So what? And then a half. Do you remember negative powers? Maybe not so much from algebra. Do you remember what happens if you put 2 to the negative 1 power? It flips it. Okay, so what? Well, that means this is 2 to the negative 1. So I've turned a half, 0.5 into a half into 2 to the minus 1. Okay, so what? So that means now I have 2 to the minus 1 is 2 to the minus x over 24,360. Do you see it now? For that to be true, this must be that. You can just cut out the 2's now. The powers have to match for them to be equal. So we can just chop out the 2's. A little trickery there. So we can just say, look, negative 1 has to equal negative x over 24,360. Now we can solve for x by multiplying by the fraction denominator, negative 24,360, and we'll have x. Or you can just look at it. I mean, what does x have to be to make this negative 1? Well, x has to be 24,360. Because 24,360 over 24,360 is 1. Is that okay? X has got to be 24,360. 24,360 years, and the plutonium will be half of its original weight. Just wait a little while. It'll be half. That was weird, huh? Does that make sense, that last step? I was just looking at this fraction saying, hey, how do I make him 1? He's already got the negative. How do I make this fraction 1? We make the top the same as the bottom, huh? The x, the top, has to be the same as the bottom, 24,360. Then that's a big negative 1. See, if x, right here, if x is 24,360, that's a big negative 1. 2 to the negative 1, 2 to the negative 1. It's true. All right, I better move on. I'll let you think about it. I know that's a weird one. Pretty darn weird.